is missing data restoration in power system. So this will be the easy course. So just take it easy and hope you enjoy it. Okay, to start with, we are going to do a warm-up game to fill in the missing number I gave you. Can you fill in the missing number here? The first one, what is number? 6. It's easy, right? How about the second one? 11? Yeah. Next one? 36? Wow. So good. How about the last one? It's hard, right? You see this way? 2 equals to what? 1 minus 1 plus 1, right? And 3 equals to 4 minus 1. And this is plus 1 minus 1. Oh. Plus 1. This is plus 1. Minus 1, plus 1, minus 1. How about missing one? 35? Yeah. So plus 1 minus 1 plus 1 minus 1 from the above one. So this should be 36 minus 31. So the next question, since we can fill in these numbers, can you find out a function to represent the number in each of the sequence? Meaning, given the position of the number from 1 to 10, can you find an equation to represent each number of it? For example, the first one, an equals to n, right? 1 to 10. How about the second one? Can you find out the equation? Plus 1 or minus 1? Minus 1, right? Okay, how about this, the third one? N squared? Yeah. Can you do the last one? With one formula.
Square plus minus 1 square over
Minus 1 square. I. It should be a function of n, right? It should be a function of n equals to, we can do this way. Based on this one, you can go into this one, right? So this one you get n squared. And how you can modify this one to the last sequence? I think maybe is close to the answer. You get minus 1 square. Minus 1 square gives you, oh, not square, not square. Yeah, square of n. Yeah, square of n. This gives you minus 1, 1, minus 1, 1, minus 1, right? This part. And add with the previous one, or minus. Because the first one is plus 1. Because the first one is plus. So you need to get a minus here to get it. The first one is plus. So we successfully get the equation for the first 4 sequences. And now is a crucial part. How about this one? Can you find a formula to do a similar thing we have done before. I cannot. Because this is just a random number I generated. I even don't know the pattern, what is the pattern inside it. So this is the main task we are going to do today. Given you a sort of complex series of number, and there is a missing value or a part of missing part inside it, and then you need to find out the pattern of this sequence of number and fill in the missing part. This function should be extremely complex. We cannot figure it out explicitly in a short time by our main intelligence, that kind of thing. So we need to use some advanced technology to find out this function to fill out the missing number. So keep this in mind. This is the main task in this lecture. But this is just a sequence of integers I gave you. In power system, do you have any idea about why they are missing data in power system smart meter data? Or even people? What is it?
There's like a disruption of communication or something, or power goes up.
Yes, that is the case. So I have summarized something for you. I categorize two types of reasons for the missing data in power system. The first one is the error in equipment. For example, the smart meter does not work for a period of time, or if the sensor is okay, but the communication link is broken, so nothing will be recorded. And another case is the storage device is out of order. So even you measure that data and you send it here, but I'm not able to store it. So the data is also missed in that way. So the second type is a man-made. I call it a man-made missing data. It's caused due to some power system operation. For example, we do demand response. In this example, we do demand response, and the load is going to go low a little bit during that period. And imagine that if you didn't perform the demand response, what should be the original profile? We never know that, right? Because in practice, we only measure the data after demand response. This red line, without demand response, we will never know that. So this we can regard it as a different kind of missing data. In some time, we need to know that to estimate how much we achieved by our operation of demand response. So that is the case. A similar thing for the CVR baseline estimation. We do a CVR, the load go down a little bit, and the baseline we never know. So we need to fill out the missing part to do further study. This is the background in the application or the cases in power system. So next, we are going to show you an example of the missing data in reality. This is the yellow or the orange curve. It's a real data profile for 1 year. This is 15-minute data. And for 1 year, from January 1st to December 31. And there are 5 days missing. This is the first one, second one. There are 5 days missing data. And for each day of them, this is the day I have from 10 o'clock to 2 o'clock missing. The missing part I mark it as 0. This is 0. This is the missing part. So if I fill in the missing part, the load profile may look like this way, something like that. So this is an example of And you are going to, after this lecture, you are going to do a homework. This is data you are given. You're going to process this kind of data and to restore the missing segments in the yearly profile. Okay. So the main part of this lecture is I'm going to introduce some methods to do the missing data restoration. There are three categories. The first is the basic interpolation methods, and the second one is regression based, and the third one is more advanced technologies, use some deep learning models. There are three specific models inside it I'm going to introduce. So let's go into the first one, interpolation. For interpolation, the simplest way you can come up with is a linear one, right? The linear, so given 2 points, the 2 red points, you are going to find out the linear equation to find out each point during the 2 points. What is the y value here given x? What is the y value? So this is a general form of it. Y equals ax plus b. And you already know that 2 red points. You can do y this one and you finally you get out this one, right? The last one, that's the equation. I'm not going to go into those details. So here, this one is the A you get, and this one is the B you get. So in this way, you can find out the linear equation. So you can find out every point in the blue line. This is the way you are going to fill in the missing data. The right bottom figure is an example I did for the missing data restoration by the linear interpolation method. This is given by a MATLAB code. This example code is given in the homework setup, so you can find out in my GitHub set. Yeah. And if you think a step further, what is the problem of this method? What's the drawback of it? Or in another way, how you can improve the interpolation method, make it more realistic? Yes, use some nonlinear function to do it, right? Because in our power system node profile, there is not likely to be a straight line between 2 points. They're going to some vibration or any kind of shapes behind two points. I think I can just go ahead.
Okay.
If I move to the next page, I think it's removed automatically.
In the other desktop switch, you did the remote desktop, it changed the settings at the bottom.
Yes.
So I don't know if that changed the settings of the pen when.
Yeah. I think I just go ahead.
Okay.
Yeah. Never mind. Thank you. So the next one is kind of a nonlinear method. It's a quadratic interpolation. So this is a little bit more complex. Given a sequence of points x0, y0. Okay, I gave up. I'm not going to use the pen. Given these points x0, 10, x1, y1, and until xn, yn, these are the points you know. And you are going to find out a sequence of quadratic function. It's a1, x squared, b1, x, c1, until the last one. So we have how many functions we have? We have n-1 functions, quadratic functions. So the first step we're going to do is write out this, because each of the function goes through 2 known points. We can do this way. The first function we do this point, right? This is this point. And the second one, we go this point. It's the same function. And similarly, we do each of them. How many equations we have now? We have right now. Yes, we have 2n equations. The answer is it's just here. Okay. The second step is a little bit tricky. For the two quadratic curves from the left and right side of each point, the gradient at this point should be equal. Does that make sense to you? Meaning the derivative here for the left curve and the derivative here for the right curve should be the same to make the whole curve derivable, right? This is the main part here. So I'm going to calculate the derivative of each curve, each quadratic function. This is the first one, and this is the second one. And those two should be the same. So I have the function like this, right? And similarly, I do a similar way for the rest of the points. And then in this way, how many equations I can get? From here to here. Yes, I get n minus 1 here. And there I have 2n. And in total, how many I have? I have 3n minus 1 linear equations. And remember our goal? This is linear. All of them are linear equations. This is the issue. The variable, what is a variable? It's not x. Yes, the variable is a, b, and c. Okay, so we have so many linear equations, and how many variables we have? We're going to find all the coefficients. Find out all the coefficients. We have 3n, right? a1 to an, b1 to bn, and c1 to cn. We have 3n in total. And can we solve the equation? Can we solve it? We cannot solve. Not exactly. We can solve it, but we cannot get to a unique solution. We have multiple solutions. And how can we make it a unique solution? We need one more equation, or reduce or remove a variable. So I'm going to do something magic. Let a1 equals to 0. Right? In this way, I have one more equation, or another way, we have one less variable. Right? So we can solve 3n variables with 3n linear equations. This way we can find out all the coefficients of those n1 quadratic functions. So this is the way. Another way is we can let an equals to 0. In similar way. Which one we are going to select? It depends on a method is it depends on how far it is, those 2 points. The distance between this one and this one. Which distance is shorter? Does it make sense? If the first distance is shorter, we are going to let a1 equals to 0. And if this one is shorter, we are going to let an equals to 0. This is a common used method to make it. So this is about that. And until now, we have talked so much about the mathematic stuff. And somebody may say, I don't care about it. I just care how I can use it. right? So in MATLAB, this is good news. You don't need to develop those kind of details, mathematical issues. MATLAB provides you a powerful tools to do it. So this is a documentation of the math work. You can find out, or you can always find out. You Google it or this thing, you can find it. This you gave some input, and this is thing I have talked about also. It's a method. You can do linear, nearest, next, different kinds of strategy to do the interpolation. You can just try it out by yourself in the MATLAB. This example code is given in the homework setup, so you can find out some details in it and you can play with it if you want. So this is about that. Next one, I'm going to move to the next category of methodology to do the missing data restoration, which is the regression-based method. It is a complex model. Don't be afraid. Don't just jump into those details. I'm going to show you some brief ideas about this method. The first thing is, this is a bidirectional method. You know do you know the difference between the missing data patching and the forecasting? Forecasting means you have historic data and you're going to forecast this part. And for missing data patching, you are going to estimate the missing part. What is the difference? What's the main difference? Biggest difference? For the forecasting, you only have the data, historic data before the period. And you are going to forecast this way. And for the missing data, you have both pre and post the event. You have additional information to make your estimation more accurate. So from this point, this work has proposed an innovative method, which is a bidirectional prediction. Go this way and then go this way. You get two results and combine those two results together. In this way, you get more accurate results. This is the basic idea of this work. And then there is another thing you can learn from it is similar disconnection. Remember, I showed you the yearly profile, and there are five days missing. And another straightforward way is you just select a similar day. For example, this is a missing data in one day, and you find out the similar day another day, and those 2 days are pretty close. In this way, you can directly use the same time period to fill it in here. This is a possible way to do the missing data restoration. This is the thing you can learn from here. And as for the details about what is gradient boosting and what is the decision tree, that kind of thing, I'm not going to jump into those details about it. This is not covered in this class, right? So remember those 2 points you can learn from this method. This will help you in your homework, right? Okay, so let's go to the next one. This is the entry of this lecture. Use some deep learning or machine learning or AI, the kind of method to restore the missing data. First of all, I'd like to ask you, how many of you have backgrounds in machine learning or deep learning or AI? Okay, that's good. No problem. I'm going to introduce some basic principles of machine learning or neural network. So don't feel nervous. It's pretty easy. I can make it pretty easy, and you can understand it in a pretty happy way. First of all, we regard neural network as a black box. A black box means we don't need to go into look inside, or we cannot look inside. It doesn't matter. Given an input, and the black box is going to do something for me. It performs some function, or do some data processing or what kind of thing, and then it gives me an output. So in our case is I feed in node profile with a missing part, and then the black box is going to give me what is the missing part, give me the missing part, and then I can combine those two together. Oh, this one here, and I get the result I need. So I reach my goal in this way. So the thing here is the neural network can do something for me. I treat it as a function. This is the input, and the function do something for me, and I get an output. The main task of neural network is to find out this function. Remember we do in our warm-up game, our task is to find out the function to help us fill in the missing data in a sequence. So this is something similar. Okay, let's go into some basic principles of a neural network. Look into the black box. How it works in the black box. First of all, I'd like to give you the result first. The red curve means arbitrary kind of group of 9 segments combined together. Arbitrary one can equals to a constant, which is a constant plus a set of blue curves. The blue curves, how it goes this way. The blue curve, I'm going to use the pen. The blue curve are in form of this way. Something like a Z in object way. For this red curve, you can see in this figure, this red curve, the first segment equals to the blue segment plus this the green segment plus the blue, right? Does it make sense for the first part? For the first part here, this one add this one add this one add this one equals to the red one. Also similarly, this one sum together get to the red one. Also a similar thing. It makes sense, right? Okay. The question is how we represent this kind of blue curve mathematically. We call this kind of curve a sigmoid. This one is a hard sigmoid. We call it hard sigmoid. But mathematically, we cannot do it in this kind of way. So we use approximate function to represent it, which is a sigmoid function. It goes in this way. Say sigmoid. There are 3 coefficients here, and those coefficients can make change to the shape of the blue curve. You can see there are 3 curves, 1, 2, 3. Each of them are in different shape. Some of them may be higher, some of them may be longer, and maybe also be split over. Everyone is different. So this can be done by the change of the coefficients here, those 3 coefficients. I'm going to briefly show you how the coefficients can affect the shape. I write a short script here. This is sigmoid. This is the original sigmoid. And we're going to change the different coefficients. This is the B. This is the B. I -1 here. So how it will change? The green one is the original one, and the red one is changed. If I minus something here, if I minus something, the curve is going to move to the right. If I plus something, it's going to move left. Right. The red one is going to move left. If I do something like this, I times a 2 here. What will happen? Can you guess it? If I plus something greater than 1. You see the difference? The red one go up, yeah, go up more quickly. And then if I do something smaller than 1, you will go another way. You see it? And then if I change C here, change it to maybe 2, and let's do this way, -1. And change everything back to the original value. You see, it's a difference. Let's just go the opposite way, right? So this is just a quick show you how these coefficients can affect the shape of the blue curves. So does this red curve same as nonlinear curves in real life? It's not, right? It's not derivable. Just like this blue curve. In reality, the curves should not have this kind of sharp color here. It's something like a smooth one, something like this, just like the blue one here. So if we have infinity number of blue curve, the red segments we can represent arbitrary kind of shape of curve. Yes. So this is a solution of this page. Any nonlinear function can be represented by a constant plus a sum of a group of sigmoid function. This is the basic idea of this one. So the question is, we have been talking about neural network for so much. How can we use a neural network to represent this function? Here it is. This is a function we have in last page. The rows coefficients, I'm going to write it in this way, x times one of them and plus a bias, and then go through the sigmoid. We call it the activation function in machine learning. And then we get a result, a value here. And then finally we times the C, which is here, and add them together. And then finally add a bias here. This is a constant. This is the green curve showed in last page. And then finally you get the output. And then this is one way. This is number 1. This is the first curve, blue curve. And this is second blue curve. And this is third blue curve. May go this way. And add them together and plus a constant, you get the output. This is a simple representation of the of arbitrary curve using a neural network. So some of you may find the problem here. The input and the output are all scalars instead of vector. So in most cases, we should expand it to a more general case, where the input is a vector. You have several components, and the output is also a vector. And this one, each one of them is called a neutron. This is how we call it a neural network. And there are a group of neutrons in each layer, and all of them together is one layer of a neural network. And in most cases, we use a stack of layers to build up a neural network. So we may have another one here, the similar thing with the previous one, and the connection to each one connect to this. This is why we call it fully connected. We connect each point together. Everyone is connected together. Now we can stack one more. However, whatever you want to do, you can stack maybe 1,000, 10,000, or the kind of layers. You can build up a really complex neural network that you can represent really complex function. And in our application, the input is a sequence. We can x1 to maybe, for example, we have daily and 15-minute data. We have 96 points in one day. So there should be x1 to x96. And the output should be, depends on how long is the missing part. For example, in our case, we set up it as the missing part is 16 points. So the output should be 16. The length of the output should be 16. And also another way you can do the output is whole day. The length is also 96. Either way you can do it. It depends on you. So this is the introduction of the basic neural network. We call it multi-layer perception. This is the simplest neural network. And then I'm going to show you the second method. This is a little bit more complex. Similarly, I'm not going to introduce too much detail. I'm going to show you the basic idea of GAN, which is generative adversarial neural network, how it works. And any one of you have heard about it before? GAN? Okay, I'm going to show you. You can find it a little bit complex. I'm going to simplify it for you. First, look at this part. We call it a generator. And then the second part, this. Regarding the two independent neural network. The first task of the first one is to generate something. This is the output. And the task of the discriminator is going to, this is the synthetic one. We make it easy, we call it a fake one. This is the real data, the true one. The discriminator take both fake data and real data as input. And then the task of discriminator is going to find out which one is fake and which one is true, and give a score to each of them. You know, the idea to find out the difference between the fake and true. And the task of the generator is going to generate the fake data that cannot be distinguished by the discriminator, meaning those two networks are fighting against each other. The first one is going to generate realistic data, and the second one is going to figure out the synthetic data. Does it make sense to you? Yeah, this is a brief idea of this kind of work. And then for the cost function design, I'm not going to show it up here. It may take too much time for that part. So since you know it, how we apply, how we do it is the input of generator is the node profile with a missing part, and the output is the generated restored profile. And then the discriminator will take the restored data as well as the real data in the raw data set, and to find out the difference, and those two networks to battle against. And finally, when those two networks are balanced, the generator is good enough to generate some good result. Okay, this is for this one. And lastly, I'm going to show you the next model. This is a more advanced one. It's a transformer-based model. I'm not sure if you have heard of transformer model before. It's the backend model for ChatGPT. You have no ChatGPT, right? This is ChatGPT is also a transformer-based model, but it's more really complex. but is the basic structure is a transformer based. So in our node profile, this is a time sequence data. But one thing you can find is very similar to a natural language task. Given a missing part of a node profile, it's similar to there is a sentence and there is a missing word in it. So we can come up with using some natural language model to deal with the missing part restoration task. This is the basic idea of this method. I've tried something in ChatGPT. Ask ChatGPT, just give it this sentence and ask him to fill out the missing word. And the result gives me French, right? I have lived in France for 5 years, so I can speak French. This is the simplest answer. But if I ask him multiple times, ask if there are any possible other possible answer, it's give me some other results, something like Quebec. This is a state province in Canada. Because French is official language there, so it's possible you are able to speak French. So maybe if you ask him multiple more times, they're going to give you some other examples, give you other answers. This is having a lower and lower possibility. So the point here is, given when you fill out the missing data, there are usually be multiple solutions with different level of confidence. That is the point here. And then in our model, the training data, we're just going to train the model with the non-trivial days, meaning you can just ignore this one. We directly use some normal days to do the training. First, I'm going to remove some data of it. Then it become a missing data, and use it to train. Go through the model and going to fill it out. This is the estimated result, and this is the real result. I'm going to compile the estimated one and the ground truth, and use that difference to fine-tune to update my parameter in my model, and finally the model is good enough to do the missing data patching. And we have talked about in the reason for missing data before in the beginning of the lecture. So we can apply it into some severe days to do the baseline estimation, given the post-severe load profile. I'm going to remove the severe period, and there is a missing part, right? I'm going to restore it, and then this one can be used as the baseline. Can be used as the baseline here. This is one example of the application of this work. So this is some details about this model. You may find it so complex, but don't be afraid. I'm going to introduce it briefly, not in too much detail, briefly. The main part is here. This is the BERT model. This is the original BERT model, a stack of attention layers, add some add and layer normalization, that kind of thing, and then input. First, we look into the input part. Remember that this model is originally proposed for natural language tasks. So in the original model, the input is language, a sequence of words. But in our application, our input is a sequence of number. It is different. So we need to do something to make our time sequence data to fit with the model. So this is the function of this part. I'm not going to into too much detail. The thing is here we have some normalization and masking and encoding method to make time sequence data to be a sequence of embedding, similar to the word embedding in natural language tasks. In this way, we can feed the data into the BERT model and the output are a sequence of embeddings. The length is the same as the input of data. For example, we have 96 points as the input, and the output should also be the length of 96 from 1 to 96. And each one of it is, when it goes through a softmax layer, it will be a probabilistic distribution of each one. So the probability means the probability of the value. For example, we normalize the value to 1 to 0 to 1, and the highest probability if it lies in 0.6. So the first value should be 0.6. And for this one, if the highest possibility here is 0.2, the first, this is 0.6. And the next one should be 0.2. And similarly, in this way, we can do a sequence of number range from 0 to 1. A sequence of like this. So in this way, we can fill out the missing part. This is the missing part, and this is the missing part. We can find out the missing value. And also we have a candidate selection method we can use to find out a top 2 candidate. Remember we talked the last page, when you ask ChatGPT the same question for multiple times, it's going to give you different answers for different times. So also in this way, we can get some different possibility of answers for a candidate selection method. So this is a brief introduction of the architecture. So this is a work. For more detail, you can just refer to it. I'm also glad to talk about more details with you if you're interested in it. As for the results,
Yeah, looking at like the back end of the data, like coming out of CVR, for example, are you taking out some of that like first data because it could be almost like a little bit loaded inflated from rising back out of CVR, or are you just taking whatever real data that you're given?
You mean the payback period?
Yeah.
Yes, this is basically a good question. For the CVR, let's take demand response as an example. It's similar, right? For demand response, usually, if there is originally a peak here, and then you do a demand response, and it will go down a little bit here, and after the period, it may go up this way, and then finally go down. Right? You mean this is the
I don't
payback.
expect it to peak that much. Maybe just like a little blip.
Yeah. Just join. My joy is so bad. It's joy in this way. Just show you there is a payback period, which is go higher after the period. So in our method, we are going to include all this part as a missing part.
Okay, so including the payback.
Yeah, include the payback period.
So does that mean that I guess from CVR itself, you might not get as much benefit because of that payback period than you might originally think?
Yes. You see, for machine learning models, most of them are task specific. It's hard to train a general model that you can work on different kind of tasks. Yeah, general model, in most cases, general model does not work well as the specific, well-designed or well-trained model. In this way, we can just, in this case, we can just train a model for a CVR data, or you train a model for demand response. Yeah, but it depends on a lot of things. If the operation time for demand response plus the payback time is the same as the CVR period, I think the model can be used both of them. It just depends on the operation time, the time slot of the missing part, including the payback period.
So I guess this also can only be used as like an analysis model compared to like using it in real time, since you have to look at the whole data set.
Mm-hmm. Yeah. Okay. As for the result, I have compiled some different models. This red one is the latest one I've introduced. This is the transformer-based model. And this one is the previous one, the GAN-based model, the generative adversarial network. And those two are some traditional classical math models, LSTM and SAE. But for the MLP, multi-layer perception, I'm not going to introduce it here. I didn't include it here because it's kind of simple network. It does not perform as well as these models. And see the results. The bird pin absolutely achieved the lowest error for different categories: percentage error, mean square error, peak error, value error, energy error, and frequency component error, kind of thing. So yeah, this is the result. Shows this one is the best model I have so far for the missing data restoration. So I think this is all I plan to show you today. And then we go into the part you may most interested in. Homework, right? I have talked a little bit about it in my presentation. The task is pretty simple. You are given a yearly profile. You have the time resolution is 15 minutes, means there are measurement every 15 minutes. There are 4 points in an hour, and times 24 hours a day, you get 96 points in one day, and you have 365 days. And the time is from in 2018, from January 1st to December 31. And there are 5 days missing, 1 day, 2, 3, 4, 5. Those missing data are removed manually by me. It's just for the task designation. The missing time of each day is from 10 o'clock to 1:45. There are 4 hours missing window, and within those 4 hours, there are 16 values. The time is constant for each missing day. Just in this figure shows this is 10 o'clock, and this is 2 o'clock. There are 16 missing values. So your task is to find out the missing data for those 5 days. So your result should be 16 points for the first day, 16, 16, 16. So you get 5 16s. In total, you need to restore 80 values for all of them. And the method is not limited. You can use whatever method. You can use just manually assign some value, or use some linear interpretation I've introduced, and some nonlinear interpretation, and use some neural network, or use some regression method, whatever. You can use whatever method. But and there is the resources I provided for you. There is a GitHub source, GitHub repository I have built here. You have the link in the homework assignment document. So you see here, this is the data. This is the yearly profile I gave you. Okay, if you click it, you can see the data. The data from January 1st to the end is the December 31. And there are 2 columns. The first column is the load data, the load profile. The unit is kW. And the last column is temperature. The temperature data is, you can use it or you don't use it. It depends on you. The missing data. Yes, this is a good question. The missing data is the ground truth. Your work is going to be evaluated by how accurate you can estimate the missing part. So you will not know the missing value right now. I'm going to upload it after the due date. Yeah, but if you want to evaluate your model, you can. Yes, exactly. You can do this way. You have the yearly profile, right? For those 5 days, you don't know. This is ground truth. We say ground truth. I'm going to use it to evaluate your work. But if you want to evaluate your model, you can just select some day of it. Select maybe 5 days or 10 days or 20 days or even more, 100 days. It depends on you. And manually remove that period. You get this date and you get a profile like this, and then you manually remove from 10 o'clock to 2 o'clock and restore that missing part and compile with the removed one. This removed one is your ground truth. You can use it to evaluate the accuracy of your model or your method, whatever method you use.
Question.
Mm-hmm.
So do we have to do this? Do we have to restrict answer only to MATLAB or we can?
Whatever. You can use whatever. Okay. And as for the resources I provide to you, I have some example code for you. One is the MATLAB. We can directly say in this way. This is the example code I provide to you. This is a linear interpretation. It's a pretty naive method, but you can get the result. You can get the missing data this way. You can adjust some parameter. I just use the simplest, the default parameter. You can just adjust something and you can get even better result. The restored one is this one. It does not look so good, but you can improve it by yourself. And another resources I have provided for you is the last model I've introduced. That is the transformer-based model. This is Python-based. This is a simplified version of this model. You don't need to train it. I have trained it and provide you with the model. I can say here. This is the model setup. You don't need to change anything. I already write it for you. So what you need to do is run this code. And then it's going to give you the result. Something like this. The green is ground truth and the red one is the estimated result. You can also try something to improve it. If you can do so, that will be great. And this is the model I'm going to load. This is a parameter. You can load into the model and do this estimation. And this is the ground truth. I'm not going to update right now. I'm going to upload it after due date. And yeah, another thing important, I almost forgot it, is your work is going to be evaluated by a MATLAB code here. I directly show it here. A test. This code is provided to you. You can, but you need to use some different data. You should create your own test data. This one is not provided to you at this time. So you need to provide to create your own test data. And then the result is calculated by absolute mean percentage error. Meaning there are 80 values for the ground truth and there are 80 values for your result. I'm going to compare those two groups of data and to calculate the error. And then as for the result, this is 7.6%. This is the error, how much error. And then, yeah, this is the grading criteria. If you can reach an error less than 3%, you get a full. Okay, and 3 to 5, you get 90%. And all the way down here. I can tell you that it's a secret. I can tell you that the example code, the MATLAB example code, can achieve 7.5% in my test set, not in your test set. Yeah, if you create a different test set, this value may be different, but in my test set, if you directly submit this example code, you can get 7.5, which corresponding to how much? You can get 80%. Okay, so there are 20% room for you to improve. You can do whatever you want. Okay. Okay, the next thing important. This is really important. You need to take care of it. You need to submit two or three stuff. The first one is the data file. Means this is your result. You have 16, 16 for the first day, and 16, 16, 16, 16, and you need to move it, form it in this way to a one. You should make it a different color. Make it a one column vector. And there are 5 days. This is one day from 10 o'clock to 1:45. This is day 1. And this is day 2 from 10 o'clock to 1:45. And this is day 3, day 4, day 5. Do you know what I mean? You put everything in one column in the time sequence. The first day from 10 to 2, the second day from 10 to 2. So you get a value from 1 to 80, from 80. Don't include anything else in the CSV file. No title, no index, nothing else, just 80 values in one column in the order of time. Okay, and the name of the file is defined here. So I think there will be, yeah, this one I've talked about it. This is the test file you can use to evaluate your accuracy. And then the second thing is you need to briefly describe your methodology. Submit a PDF file and name it this way, and describe your methodology within 100 words. Make it simple and make sure you cover everything in your methodology. And last, the second one is you should plot out your restored result. Something like this. This is the example. Something like this example. 5 days, 5 sub figures, and each of them you plot out 1 day, and you don't need to draw the ground truth since you don't have it. You just draw the red line or other color, what color you want. That's okay. just let me see the restored profile, how it looks like. That will be fine. And the last one is, this is optional. Depends on your method. If you are not going to do any coding work, For example, you just manually fill in something, you don't need to submit this one. It means if you do some coding work, you need to submit your source code and put everything in one folder. And the folder name here this way, and compress it into a zip file. Yeah, and submit it. Pay attention that don't include any data, only your source code, nothing else, only source code, because just to reduce the file size. Okay, that makes sense? So you can read it later. I'm going to submit. I think it's already in the homework, the driver for the homework. You can figure it out. Let me check what's anything else. Oh, okay. Another thing important, that is important, the time of the homework.
Are we submitting this on Moodle?
Where do you usually submit your homework? In Moodle? Yeah, okay. You just do it as usual. Let me see the homework. It will be homework 6. It's assigned today. The due date will be on the day before spring break. You can check it later on here. Yeah. So you can start to work on it. And if you have any questions, feel free to let me know. Yeah. So do you have any other questions today?
What about homework 5?
Homework 5?
Do you know anything about it? Or no?
You mean homework 5?
Yeah, like I don't know what the instructions
You don't find the instruction?
we have like the
I
Excel
think
sheet.
you have something in
We have the
here.
Excel sheets and the MATLAB files, but not like
Oh, I don't see anything here. Let me. Anything on Moodle? Sure.
Python. If you are using MATLAB
Mhm.
as a platform, can you help us translate that into MATLAB?
Yes, that's the one point I forget. You can try something to call the Python file from MATLAB. I think there is some ways to do that. But another way is you can just configure a Python environment. That will not be too hard. I have some instruction to you. Yeah, that's a good point. I almost forget it. I have some instruction on the README this page. You can see introduction. This is the data, and this is MATLAB code, and this is the Python code. You can use it or not. It depends on you. And the thing is, you need to configure a Python environment. Some of you may have experience on it, but some of you maybe may not. So some instruction for each step. This is a brief introduction. For example, in each step, you don't know how to do it, you can search on Google. I think it's not too hard. And it will not require, it does not have much requirement on your computer. Yeah, it does not require any training. It just run it. I think it's pretty simple. It will not be too computationally expensive. You can check it later. If you have a question, you can ask me, drop me an email. I'm going to explain more for you. As for homework 5, I'm not sure where is the instruction.
okay, that might be it right there. I just had to check.
Yeah. What's the due date? I think is earlier. Okay, next week. Yeah, maybe you can just send an email to Dr. Lu to ask where is the instruction. Anything you can get from him, from her. Okay. Any questions? Any other questions? Okay, if not, I'm going to end this course. Thank you for coming.